Francisco came.
Hello, hello. This is SIG Node weekly meeting. Today is October 3rd, 2023. Welcome, everybody. We have few topics on agenda. I also want to mention that we have cap freeze this Friday. So if you're running any caps, please make sure that PR is approved and all the metadata is up to date. Typically, release managers will go into every cap issue and post those updates there. So yeah, watch for that. That said, we have a first topic from Viping and Ian. I will give them a floor.
Hey guys, yeah. So this PR, right? I think it has been quite some time. So we are trying to fix the issue when in static CPU policy, uh, the, the pod shouldn't be scheduled into reserved CPU, right? Yeah. And then now here comes to uh, a discussion about the shared CPU pool can never be empty, which is a side effect of the PR fix. Okay. Like we expect it to never be empty, right? But the PR can make it empty. So I think Swati she left some comments saying two things, right? One is already behaving that way, like shared CPU pool can never be empty. So we should keep it this behavior, otherwise it would be a regression. The other thing is like due to C group V2 thing. So if we allow shared CPU pool to be empty, then it will jeopardize the guarantee of exclusivity of the pods. Okay. Okay. So I think we are clear that shared CPU pool can never be empty. Okay. So, but it's just how we're gonna address it. So right now the PR fix is like I exclude the reserved CPU from the shared pool, and so right now essentially the guarantee pod can claim all the CPU from the share pool, right? Because the reserved CPU is in the share pool anymore. And then I'm thinking of just changing changing the check in the admission time during CPU assignment. Is it good enough? I can share the comment here to be more clear.
Yeah, Whipping, can I add a couple of things? So I think that there's an idea discussed on the PR about the shared pool never becoming empty, and why we should prevent that. And I think that's kind of core to my confusion on this topic. Is I don't see a good reason why the shared pool should be disallowed from ever being empty. Like I think it's sort of, there's a check in the code that says if the shared pool is empty, throw an error, right? But why do we think that's not just a hack? If someone wants to allocate all the shared pool with exclusive CPUs, that's their prerogative. That's one of the features of the static CPU policy. They can do this, I think. And if there's some downstream effects of depleting the shared pool, like it sort of maybe it makes the CPU set of the shared pool go to 0 or go to empty set, and then it inherits the parent's resource set. I think we can deal with that in a sort of special way, maybe. But I don't feel like we should just kind of do any kind of resource-based restrictions just based on some kind of vague concept that it currently exists in the code,
So the code tries to validate the situation what you cannot have empty pool if you have at least one consumer for it. So if you have any burstable or best effort pod which is running on the node, it needs to be assigned somewhere.
Yes.
So if it's not guaranteed, then in static policy, it's the only place where it can be assigned, it's to shared pool.
Yes,
but
but
and that means it cannot be empty.
Well, what you're saying is a person doing a Kubernetes deployment should not deplete their shared pool, right?
You shouldn't end up in a situation on the node where you have only reserved pool, but you don't have any CPU left for the shared pool.
Yeah, but
because you have like CNI plugins, you have loggers, and a bunch of other like kube system components which are still running as a pods, and those are usually inside shared.
Okay, very good. So shouldn't someone maybe the architecture is different? Maybe if we're allocating some specific resources for those things, maybe that should be accounted for explicitly. And aren't there already tools to do that? Like, isn't that what Kube Reserved and System Reserved is for?
Theoretically, yes, but I'm not sure what those are two working correctly. And especially in the scenarios when you have changing amount of system components. So for example, like the system reserved and inside kubelet, it's a static number. But like you can have by many of deployments in kube system namespace, which probably should shrink or grow that pool.
My fundamental problem is it feels like we're just sort of accepting this as a limitation, I guess, but it feels like we just don't have the right tools to kind of express this reservation, and we're using reserved CPUs to kind of duct tape with it. But I think we need to be asking like what the right way to kind of solve this problem is versus just relying on reserved CPUs being enough to actually run any burstable stuff, some of which is specified by the user and some of which is not.
Hey
So
guys,
the problem here is what we have like two overlapping scenarios. So like CPU set is only capable of doing integers. You cannot have 0.5 CPU and CPU set. And reserved CPU, we can put any number. So reserved CPU setting in kubelet is serving the purpose of accounting between the scheduler and kube, like how much we can fit. And that includes like static pods, it includes like system pods, everything pod is running on one node. Plus also, if I remember correctly, like the thresholds for pressure and eviction on one nodes. But static policy is not able to handle it properly. So what like how it was done in the past, it was shared pool plus reserved CPU is one big CPU set, and kernel scheduler just make sure what like appropriate quotas and limits are applied to this. So yes, we're sharing like cores from 0 to 5, but there is no like hard distinguish, like one core 0 to 3 is system pods and 4 to 5 is for burstable.
Okay. Thanks, Alexandra. So yeah, we understand that share pool cannot be empty. Okay, but I'm saying so as I remove reserved CPU set out of shared pool, right? Can I just change the admission check? So it failed in admission stage when grantee pod want to claim all the CPU from share pool. Is it a good solution or some other better way?
You might end up in the rounding problems. So if you have at least one burstable or best effort pod, which is consuming like 0.5 CPU, you will get into a scenario where you either cannot admit the guaranteed pod, which Node still thinks it's possible to fit, or not Node, scheduler. Or you will end up you will try to remove a CPU core from the CPU set for shared pool, and suddenly your burstable pod ends up nowhere.
Why would that happen? it failed at the mission stage, right? Let's say you have a CPU on the machine, like 6 has been used, okay, and then so two CPU there, and then there's one guarantee port want to claim 2, and then I change the admission check to be if the request CPU equal to current available CPU, then I decline false. Then you won't claim the 2, right?
You mean for guaranteed? Yeah, that might work.
Okay.
Of course, it needs to be tested, but sounds logical.
Yeah. Okay. Okay. Uh, can anyone here follow up with me with the comment I paste here, or still Swati gonna is the only person who will follow up?
Sorry, Whipping, what's your request?
Yeah. Can someone follow up with the comment like I paste here? Is this solution good enough? So last time actually I tried to do what I say locally, and then the test failed. I don't know. I don't know why. Like logically, as you mentioned, Alexandra, like it sounds reasonable, but some tests fail. I don't know why. Is can someone follow up with me? Like familiar with the workflow?
If you think Swati isn't on the call whipping, but we can poke her again on the thread we already had on SIG Node, that you have an update and if she can take a look.
Okay. But I think her time zone is a little bit different, right? Is it possible to have a meeting with her? Generally, how do you guys do follow up offline?
Usually asynchronously in the pull request. But you can also put ping in the chat in Slack. And actually, Francesca, Swati, myself, we are in Europe time zone. So if you are in China, we have quite many overlap hours.
Okay. Yeah. Okay. I see. Yeah. What do follow up? Thank you, guys. Yeah.
Thank you. I think this concludes the first topic, and second topic from Mo.
Hello. Can you hear me?
Yes.
By the way, somebody's sharing screen. I can't actually tell. Zoom is being weird.
Nobody's sharing, but if you want to share, I can make you co-host.
No, I don't need to share. I was just confused if I'd lost the screen somewhere because Zoom is weird. So I wanted to bring up a topic around basically what I'm looking to build is the capability of having image pools that are authenticated using the Kubernetes service account token associated with the pod, right? So today the kubelet supports the concept of a kubelet credential provider, which is configured at the kubelet level. And it can basically tell the kubelet what credentials to use for like what images. But it doesn't have like the concept of the service account that was used to do that flow. This was discussed when the kubelet credential provider cap originally went in, and it was just sort of deferred. But I'm sort of looking to restart that discussion. I will obviously have the same discussion in SIG Auth, but this would basically end up being a co-owned thing between SIG Node and SIG Auth. So I wanted to bring it here and to see if well, if there was any concerns, if anyone had any ideas related to this flow, or just any comments or discussion folks wanted to have in regards to it. There's probably a lot of gotchas here and there, but
What is the status of this work? Are you trying to get something done in 130, or do you want to do it earlier?
Yeah, so my hope would be to write a KEP probably around the end of this year for inclusion in, I guess, 130 for an alpha. The parts that are not super clear right now are like what Kubernetes API changes are necessary. In particular, as far as I know, most credential exchange mechanisms require some extra metadata so that the service account token can be exchanged for some other cloud-specific credential. That I believe that forces a requirement of a Kubernetes API change, so that there is some config to let the backend even know what token to exchange for, which is unfortunate. I was kind of hoping that I could somehow have this just at the kubelet credential provider layer, so it would just sort of be a detail in the kubelet and not necessarily surfaced all the way through the Kubernetes REST API. I think there's also questions around how you guarantee that the authentication check is always made. I haven't read the insured secret images pull cap, but that might help. Maybe.
So that cap is about splitting authenticated and non-authenticated downloads. I'm not sure how it will help here.
It'll help by forcing the authentication check.
Yeah, that was my thought process, right? Is that
without having pull always being a requirement, right?
Right. The other aspect is right now, I think the kubelet credential provider, when it caches back their credentials, they can be scoped pretty broadly. I don't think that would make sense if you're using the service account token as the authenticating identity, right? Like 2 pods with different service accounts shouldn't be able to use the same image secret, basically.
Right.
So there's some nuance and coordination there, but yeah. But yeah, I don't know. Does anybody have? Oh, sorry.
Yeah, we can. Sorry, we can go over the code for the verification of this. The key ring secret you're talking about that's injected by the service provider integrated in kubelet. We can go over that code.
I'm also looking for motivational part. Is there any write-up right now that will help understand better who needs it, why they would want it, and I think having motivational part will help greatly to understand who want to work on that.
Yeah. So certainly I would include that in the pre-kept docs and stuff. The generic motivation for us right now is that we want to enable people to host private images in their registries, and then not have to manage like image pull secrets. And it's nice to be able to assign that, like, hey, I have this, I don't know, this to-do list app. It is allowed to pull the to-do list image to run. And so the way you would end up wiring that through is you would assign the service account to have some identity in your registry. So when the token is used to pull, that identity can be mapped to some authorization, which then sort of completes the whole picture. You don't have any long-lived secrets anywhere. You just have configuration, and that allows the pull to happen. So that
makes sense. Yep.
Yeah.
And then you want some kind of an image policy to make it inviolate against all the other pods that might also be trying to do a pull of the same image, but don't have access. I got you.
Right. So
yeah.
we don't want it's okay to not re-pull the image as long as you verify the authentication, and that's actually ideal. It's just that it's more nuanced, and I definitely don't want to like.
It's definitely nuanced, and you might want to say for the next couple hours or something, right? Kind of thing as well, because it could be an expiration on that authentication.
Yeah, that's fair too.
Yeah. Let's get together and chat. Peter, we had a little work group going that was starting to highlight some of these kinds of image pool policy type things we might need going into the future. And I think you've got a nice pattern that we talked about a little bit, but not in this level of detail that you're talking about right now.
Okay, yeah, that sounds good. So I think next steps for me were I was gonna bring this up in SIG Auth. I think that's in a week and change. But then I can also you said Peter. I don't know which Peter you're referring to, Mike.
Peter Hunt, Harry Commander.
Peter here.
Okay. So I will make sure to ping you guys on the discussions and on I guess Kubernetes Slack, so that way y'all are aware if you want to join in on like the SIG Auth one and any future.
Sir, are you also interested?
I didn't hear that last part.
I was asking if Sergi was also interested on that conversation.
I try to join those. Yes.
Yeah.
Okay. Yes,
Well,
I will ping you guys and make sure. Also, if you guys are at KubeCon, I'll be there if you want to chat in person.
Oh, excellent. Yes, I'll be there.
I and Riven are also interested. We already had one discussion on Slack before, so if you could also add us.
Okay. I'm gonna ask people, can you please write your names down into the doc? I will start.
Sure.
Now we're at the limit of what my mind can remember.
Sure. Yeah.
The stack hit the heat.
Yeah. Except I have a circular buffer that very quickly overflows and just starts eating itself.
We need a shared buffer, I guess. Yeah.
Okay. But that's all I have.
Thanks, Mom.
okay, we have the last topic left. Peter?
Hey, I'm coming in at not quite the 11th hour, but quite close to it, probably like 9th or something. This caps the proc mount. Well, it's actually not a cap technically. It predates caps. It's been in alpha since like 1.12, and so it recently came up internally in a discussion, and so I decided to open up a cap to push it to beta, and so it wasn't tracked in the list, but I'm hoping that we can get a little bit of just a little bit of attention to it. It's not a super high priority, but if folks have reviewing time to look over it, I think the feature is fairly stable at this point. It just kind of we just need to do the paperwork to get it over the finish line. That's it. Just wanted to illuminate and discuss if anyone had anything they wanted to mention about it.
Yeah, I would just say this is useful for like user namespace scenarios where you're nesting containers within pods and so on. So if folks have such use cases, this might be of interest.
Yeah, I was going over a simple scenario with OpenSSL the other day, and it was definitely hit in this area. Very cool.
Okay, thank you for bringing it in. We can continue discussion online. Yeah, I think we reached the end of the agenda. I know that there are many caps that currently actively discussing, so maybe we can spend the rest of the meeting with reviews and looking at caps. Any more topics?
No, I'll pick Peter. Definitely interested in this unmaxed proc mount to see how we decide who's allowed to be unmasked. Yeah, it's interesting.
Sorry, I didn't get it. You interested in what?
No, I was just looking at Peter's new security context with an unmasked proc mount. It's interesting to look at. I was curious, Peter, if there was any way to define who's allowed to do that, right? Or is it, who's going to manage the new policy? I guess is the.
My audio is being very choppy right now. Are you able to hear me? I could read the captions. I might have to switch
I can hear you, Peter. Yeah, I can hear you.
Cool. So your question was, is there any thing to say who, which containers are allowed to use this?
Yeah.
Yeah, so it's integrated into, so it was originally integrated into pod security standards. Oh no, it's not. It is now integrated into the pod security standards or pod security mission. So it's part of the baseline policy. So if there's a workload that's restricted, it won't be able to access it.
Okay.
Yeah, I actually remember this a little bit with Jesse Frizzell. That's interesting. Yeah, that's an old issue. I remember that one.
Yeah, she started it off, and I'm basically picking up with her work.
Cool. All right.
Okay, if there is no more comments and discussions, let's wrap it up. Thank you, everybody. Bye-bye.